the first thing I'm going to teach you is something called formal charge. Formal charge is when it asks you to pick the most likely Lewis structure. So this is for when, like, you can choose to put the double bond here, or here, or here. Or you can do like a triple single, where you're kind of just deciding wherever things go. For formal charge, you would draw all of the options and then use formal charge to pick the correct option, okay? So the example we're going to do is carbon dioxide. Carbon dioxide is 4 plus 6 plus 6, so 12 plus 4, 16. So we have OCO minus 4 is 12. But if I did this, my carbon would be super naked, right? We have 2 missing spots, so we can't do that. So then we have options here. Probably what you would do is this, which adds up to 16. But you could also do this. That also adds up to 16 and carbon's not naked. And I just randomly picked the left side, but I could also put it on the right side. So that showing all the options is actually called resonance, which is going to be our next topic. But formal charge, I'm going to use colors. I'm going to actually use all of the colors for this. I'm going to do it in those colors. Red minus green equals blue. So formal charge theory is that when an atom or an element has only like 6 valence electrons, and we compare it to how many actually are being used, the ones that are even Steven is more likely to happen. Okay, so what you have to do for formal charge is you have to do each element separately, and you're looking for it to turn out to be zeros and negatives. If it turns out to be positive, it kind of like gets eliminated. Okay, so watch. For this oxygen here, I'm going to take my valence electrons. Remember, which are just the group numbers. So oxygen has 6 valence electrons minus the used electrons. So that means oxygen has 6 electrons ready to do something. And of those 6, I'm using 1, 2, 3, 4, 5, 6. It's the touchy ones. 6 minus 6 equals 0. 0 is the formal charge. You have to show me work on this. Not really, but just to learn. Okay, so carbon is in group 4, so it has 4 valence electrons minus the touchies. 1, 2, 3, 4 equals 0. So that carbon has a formal charge of 0, which is good. You want zeros. And then let's do this oxygen here. Oxygen is group 6 minus the touchies. Also equals 0. You might draw it that way just because it's more symmetrical, but the formal charge proves that this is the most likely structure. We're going to do these two though. Go ahead and do these two, each one. Do the minuses for each one with your battle buddy, and then we'll check to make sure which one's the winner. Oh. to talk about resonance. You've seen this before. Let's do it with NO2 minus. So nitrogen is 5 plus 6 times 2 plus 1. So 12 plus 6. Minus 4. If I did this, nitrogen would be missing his pants. So you can't do that, right? So we're going to double bond. But this is an example of I'm just like randomly picking this side to double bond. But I could also, it wouldn't matter if I picked the other side. Resonance is when you draw all of the options. Only do it when it asks you to do it. So it'll say, please show all resonance structures for. That means you're going to have to flip-flop your double bond. You're going to have to do all of them. Okay? To choose the most likely structure, you would do formal charge only when it asks you to do that. But what I want to tell you about this is the actual bond is an average of both. So I know in honors chem or baby chem, we kind of explain it like the electrons switch from this side to this side. Electrons aren't things, so they're not really moving. It's the answer, like they can actually do some data on this, is the bond lengths are actually a 1.5. So if it's a 2 and a 1, it's actually 1.5, 1.5. Okay, so the way you would draw that, if it asks you to or discusses it with you, is like this. It's not a double, it's not a single, it's a 1.5. So you would take the average of the two for resonance. So in terms of let's average length, we learned yesterday that the single bonds are the longest and the double bonds and the triple bonds. So it's this one is a double bond. If you talked about it, you'd be like, it's shorter than this one. It's actually, they're both a 1.5. So it has average length, it has average strength as well. It has a strength of 1.5, it has a length of 1.5. When Justin Bieber sings to you, can you just explain that to better to somebody than I did? Where'd they go? Come on. So this has we had a unit on enthalpy. Chapter 5 was on enthalpy. Now that we know what enthalpy is, there will be a little bit of enthalpy in every unit. This is on bond enthalpy. Enthalpy is just the amount of energy. So bond energy is how much energy is stored in those bonds. And it comes off a charty chart that I made a copy of. It's on the back of your notes. I was going to cut them in half. That's why you have two of the same thing. But then I was like, no, let's take notes on it. So you have double them. For the quiz and the test, I just like typed it into the problem. So you only need this for like the homework and stuff. But if you take a look at them, they're just separated by bonds. On the top are all the single bonds, and on the bottom are the double bonds. So that's why it relates to this unit. You have to draw the Lewis structure in order to know whether it's a single bond or a double bond. This enthalpy is the only one that's going to be backward for us. All the other charty chart stuff has been products minus reactants. Bonds are the only one that's backward. The only one that all year that charty chart numbers are backward. It's actually going to be reactants minus products, and that's because it's broken minus formed, and we have to break the reactants in order to make the products. We're actually going to learn this by using a sample problem. We haven't even touched our sample problems yet. We've been doing them other ways. It's in the PowerPoint notes that we haven't even touched for this unit, and today's the last day of learning. So in the back of your PowerPoint notes, we're going to do sample problem 11. I think we did 1, maybe. Okay. I don't know, for this unit I think it's better to actually draw them than to just look at them, so that's why we did handwritten notes. That's like me deciding the day before. Okay, so the reason this fits into this unit is because the first thing that you have to do is draw all the fluid structures. Because you need to know whether it's a single or a double bond. And maybe you are good enough that you can just know without adding and drawing, but you know, just to be safe, I would suggest that you draw them. So it says using the bond energies listed in 8.4, which is the chart I printed for you. Calculate enthalpy for the reaction of methane with chlorine and fluorine to make freon. So we have methane CH4. Draw the Lewis structure. Because not only is that going to show you it's a single bond, it shows that you have 4 of them. There's 4 bonds in that. Plus balanced equation, 2 diatomic chlorines. This is just how I'm thinking. Chlorine is 7, 2 of them is 14, minus 2 is 12. Maybe you need to draw your dots to know that that's a single bond. Maybe you don't. And I have 2 F single bond Fs. They're also in group 7. So 14 minus 2 is 12. So I know that's a single bond as well. What am I making? I'm making the CF2Cl2. So my carbon in the middle. I learned how to draw dipoles, so I know in a tetrahedral to put my F's together, just in case I need to draw a dipole. Okay, but carbon can't have more than 8 bonds no matter what, so I know everything's going to be single for that, right? Like there's no, I can't double bond anything because that would be more than 8. Carbon's one of those that you can. Plus 2 HFs, so for that I have 7 plus 1 is 8. So I know that's going to be a single bond, 2 HCl. 7 plus 1 is 8. Okay, so now watch the math. This is the only chart that's backward. We're doing reactants minus products. Every other time we do the other way. We do products minus reactants. So enthalpy equals. I'm going to do my reactants first. I'm looking at my chart, my bond chart. I have 1, 2, 3, 4 C single bond H's. So I'm looking at my C single bond H's upper left hand corner. It's 413. So I have 4 of them at 413. Plus I have 2 coefficient. I have 2 of Cl single bond Cl. Cl, single bond Cl is 242. And I have 2 F single bond Fs. For my reactants, because bonds are backward, they're the only time I'm doing my reactants first off of chart numbers. Okay, go ahead and do the products. Go ahead and do the products. Pull them off the chart. Use your coefficients. Count your bonds. Bonds are lined. And then push your buttons when you're ready. did you get? Negative 1176. Okay. You can finish your whole worksheet, which has practice on these 3 things. You have a lab due at the end of the hour tomorrow. You have a review in the basket. Your quiz is going to be Tuesday. Okay, so manage your time how you want to manage it. Maybe get your lab done first. Oh.